Hi, welcome to the third tutorial under the section called Financial Mathematics. Today's tutorial is titled Loans and Annuities. In today's tutorial, we are going to be looking at loans and annuities and how to derive the standard formulas for both of them. In terms of what you need to know, you need to be familiar with the first two tutorials under Financial Mathematics titled Basic Financial Maths and Using the Timeline. You also need to be very familiar with the section called Sequences and Series, with specific reference to the geometric sequence and series. This is mainly grade 12 work. However, if you are in grade 11 and have coped well with the first two tutorials under Financial Maths, then have a go at this as well. Let us begin by taking a look at a basic definition of an annuity. An annuity is an investment whereby you pay a fixed amount at regular time intervals into the investment and it grows, earning interest to yield a future value. Let us use an example to illustrate. 200 Rand is invested monthly at 14% per annum for 2 years. What will its value at maturity be, or its future value? There are two ways we can calculate this. The first way, we could use a timeline. Now we invest 200 Rand. In 1 month's time, we add 200 Rand to that. In 2 months' time, another 200 Rand. In 3 months' time, another 200 Rand, and so on until we get to 24 months. Notice how tedious this will become, as you will have to add up all of the different future value amounts. It will be 200 Rand, open bracket 1 plus 0.14 over 12 to the power 24 months, plus 200 Rand, open bracket 1 plus 0.14 over 12 to the power 23 months, plus 200 Rand, our interest to the power 22 months, and so on up until we get to 200 Rand times by 1 plus 0.14 over 12 to the power 0 months. Now think about this. Is this not the same as a geometric sequence? The A value is 200 Rand. Our ratio is 1 plus 0.14 over 12. And the number of terms is 24. The standard formula for the sum of a geometric series is Sn is equals to A, open bracket, r to the power n minus 1, close bracket, all of that divided by r minus 1, which in this case would be 200 times by 1 plus 0.14 over 12 to the power 24 minus 1 over 1 plus 0.14 over 12 minus 1, which will give us an answer of 5,502 Rand and 64 cents. That is the value of our money at the end of the 2 years, or rather, that is the maturity value of our annuity. That brings us on to our standard formula. Future value is equals to A, open bracket, r to the n minus 1, close bracket, over r minus 1. Now, think about this for a minute. What if I change that standard formula slightly to this? Future value is equals to A, open bracket, r to the n minus 1, close bracket, over our interest. Why? I want you to think about that for a bit. Now you have a go at the following. You invest 700 Rand every 3 months into an investment paying out 15% interest for 10 years. How much is your money worth at the end of the 10 years? press pause on your DVD player and have a go at this. Welcome back. Let us take a look at what you should have got to. We are investing 700 Rand each time, which means that our A value is 700 Rand. Our R to the power N value is 1 plus 0.15 over 4 to the power 40. The reason it's over 4 is because every 3 months we are investing 700 Rand, which means that our compounds are 4 times a year. The reason it's to the power 40 is because it's 10 years times 4 compounds a year, n times m. That means that future value is going to equal A times by R to the n minus 1 close bracket over our interest, which is going to equal 700 Rand open bracket 1 plus 0.15 over 4 to the power 40 minus 1 close bracket divided by 0.15 over 4, which gives us an answer of 62,727 Rand and 7 cents. Because each amount was earning interest, notice that we only put in 28,000 Rand over the 10-year period, but we got out 62,000 Rand 727. Annuities can be very powerful forms of investment, but it has to come over a very long period of time. Let's now take a look at loan repayments. Are loans that different from annuities? Not really. With an annuity, you are paying into an investment a monthly amount saving towards a future value. With a loan, you are drawing a certain amount at the start of the period and paying it off monthly. A loan is essentially the exact reverse of an annuity. Let us take a look at the standard formula when working with loans. Present value is equals to A open bracket 1 minus R to the negative n close bracket divided by I over M. Now remember, I said that with a loan it is the exact reverse of an annuity. Instead of future value, we've got present value is equals to A. Our A amount is still our repayment amount. Open bracket 1 minus R to the negative n. Firstly, it's swapped around. It's not R to the n minus 1, it's 1 minus R to the negative n. And instead of it being R to the n, it's R to the negative n. Divided by I over M. M is the number of compounds per year. So pretty similar, slight changes from the annuity standard formula. Let us use an example to illustrate. We are paying back 300 Rand a month for 3 years at an interest rate of 13% per annum. What is our loan amount? Present value is equals to 300 Rand, which is our A value, times by 1 minus 1 plus 0.13 over 12 to the power negative 36. It's 0.13 over 12 because it's 12 payments a year, 12 compounds a year, to the power 3 years times by 12 compounds a year, which is 36, divided by 0.13 over 12, which gives us a present value of 8,903 Rand and 68 cents. Alright, now I want you guys to have a try at this. You buy a car costing 60,000 Rand on loan over a 5-year period at an interest rate of 14% per annum. what will your repayments be? I want you to press pause on your DVD player and have a go at that. Remember, you are working out the A value, you are working out your repayment value, and you've got your present value of 60,000. Press pause. Let us have a look at what you should have come to. The standard formula is present value is equals to A times by 1 minus 1 plus I over m to the power negative nm, all divided by I over m. Remember, we are looking for A. I'm going to use simple formula manipulation to get A on its own before I plug in values. A is going to equal present value times by I over m, all of that divided by 1 minus 1 plus I over m to the power negative nm. That means that 60,000 times by 0.14 over 12 divided by 1 minus 1 plus 0.14 over 12 close bracket to the power negative 60 is going to equal 1,396 Rand and 10 cents. That means that at 14% interest, if you had to take out a loan of 60,000 Rand over a 5-year period, your repayments would be 1,396 and 10 cents. Notice how financial maths is becoming more and more relevant to you. There are 2 exercises that I want you to do. The first exercise I've left in the workbook, and I want you to have a go at that before progressing on to tutorial 4. The other exercise I want you to do, I want you to have a look around you. Go through your local property pages, go through car magazines, look at the prices of cars and houses and their relevant loan repayment amounts. Also, I want you to have a look at possible annuity options that are available to you. In the next tutorial, tutorial 4, we will be going through advanced financial calculations. I look forward to seeing you guys there.